Here we have to solve for x in the given exponential equation. Okay, here we have the variable, the exponent, and whenever we are trying to solve for the variable that is the exponent, what we need to do is we have to get the same base on both sides of the equation. Once we get the same base on both sides of the equation, we can equate the exponents and we can solve for the variable. So here we have the base 5. Here we have 25 inside the square root. Anyways, 25 is the power of 5 because it can be as 5 square. And here already we have 5 inside the square root. So I think we'll not have a problem to get the same base on both sides. That is 5 because we have base 5 and this 25 is also a power of 5 and already we have 5. Okay, now let's do some simplification on the given equation. 5 to the x power equals to, and already we know that square root of 25 can be written as square root of 5 times 5. So whenever two numbers are multiplied inside the square root, one number will come out. So square root of 25 equals to just 5. So now we can replace the square root of 25 by just 5, and we have exponent negative 7 over here, 5 to the negative 7th power. And here, so we have square root of 5, and this square root can be written as exponent because we cannot simplify this square root as we have done for square root of 25. Okay, so because the 25 is a perfect square, so we are able to simplify square root of 25 as 5. But here 5 is not a perfect square, so we will not be able to simplify square root of 25. So for that, what we can do is we can write this square root as an exponent. So whenever I write square root as an exponent, it will become just 1/2, and already we have negative 5 as an exponent. Okay, so 5 to the x power equals to 5 to the negative 7th power times. Okay, here I can use the power of a power rule in exponent. That is, let's consider base a with the exponent m, and for the whole stuff we can consider the exponent n. Okay, whenever we have two exponents like this, what we can do is we can multiply the two exponents, that is m times n. So the same thing we can do over here. We have base 5 and we have exponent 1/2, and for this complete stuff we have the exponent negative 5. So what we can do is we can multiply the two exponents over here using the power of a power rule in exponents. So when I multiply this 1/2 and negative 5, what do I get? So 1/2 times negative 5 will be 1 times negative 5 will be negative 5 over 2. So when I multiply this 1/2 and negative 5, I'm getting the exponent negative 5 over 2. Okay, so 5 to the x power equals to, here I multiply two terms with the same base. Let's consider the product rule of exponents, that is a to the mth power times a to the nth power. Here I multiply two terms with the same base. Whenever I multiply two terms with the same base, I can take the base once and I have to add the exponents, then I'll be getting m positive n. So now I get, so when here I multiply two terms with the same base 5, so I can write the base 5 once and I can add the exponents. So when I do so, I'll be getting negative 7, negative 5 over 2. Okay, here two terms are equal with the same base 5. So whenever two terms are equal with the same base, what we can do is we can equate the exponents. So when I equate the exponents, I'll be getting x equals to negative 7, negative 5 over 2. Okay, now we are in the position to simplify this one. Okay, here an integer and a fraction are in subtraction. So whenever a fraction and an integer are in subtraction, we have to multiply the integer by the denominator of the fraction. So once I'm done with this multiplication, I can take these two as a common denominator. Okay, if I multiply this negative 7 by 2, it will become negative 14. Now I am done with the multiplication. Now I can take these two as a common denominator for both the numbers. Okay, now I get x equals to, when I combine negative 14 and negative 5, it will become negative 19 over 2. So I have solved for x in the given equation. The value of x is negative 19 over 2.